The story of a Boeing 747 attempting a takeoff from an aircraft carrier is one of those unbelievable aviation tales. That sounds like pure fiction until you start digging into the details. Imagine the sheer size of a jumbo jet, an aircraft that normally requires well over 10,000 feet of runway to get airborne, being maneuvered on the narrow pitching deck of a carrier at sea. The image itself is almost surreal, but the concept has captured the imagination of aviation enthusiasts for decades. To really appreciate what this attempt meant, you have to consider the aircraft itself, the carrier environment, and the incredible challenge of marrying the two worlds together. The Boeing 747 was designed in the late 1960s as the first true wide-body commercial airliner, often nicknamed the Queen of the Skies. It was built to carry hundreds of passengers across continents and oceans, and it quickly became a symbol of global travel. At its core, the 747 is powered by four massive turbofan engines, depending on the variant ranging from Pratt & Whitney JT9Ds to General Electric CF6 South or Rolls-Royce RB211s. Each engine produces tens of thousands of pounds of thrust, which collectively allow this giant to lift maximum takeoff weights that can exceed 800,000 pounds. To put it simply, this machine was never meant for short runways, and certainly not for the cramped deck of a naval carrier. Carriers are designed for fighter jets, reconnaissance aircraft, and occasionally specialized cargo planes, all built with short takeoff and landing performance in mind. A typical carrier deck offers a runway length of around 1,000 feet, far shorter than even the shortest runways used by civilian airports. Fighters like the F/A-80 and Hornet can manage such conditions thanks to powerful engines, lightweight airframes, and catapult launch systems that throw them into the air. A 747, by contrast, is in another league entirely, requiring acceleration, runway length, and lift that a carrier deck could not reasonably provide. Yet the thought experiment of whether it could work reveals just how much performance is built into the airframe. The design of the 747 is an engineering marvel. Its distinctive humpback upper deck allowed for both passenger seating and the possibility of a nose door on cargo variants, something unique among airliners. The wingspan stretches to over 195 feet in the earlier models, with carefully engineered wing sweep angles designed to balance long-range efficiency with stable handling characteristics. Those wings are also flexible enough to endure enormous aerodynamic loads while providing the lift necessary for a plane of such size. Control surfaces along the trailing edge, including massive flaps, are key to generating additional lift at lower speeds. These features, combined with the sheer thrust of the engine, are the only reasons why anyone would even dream of attempting a takeoff from something as small as a carrier deck. Performance aspects of the 747 highlight just how challenging the carrier scenario is. At maximum weight, the aircraft needs a takeoff run of nearly 2 miles to reach rotation speed, often around 160 to 180 knots depending on conditions. On a carrier, that's impossible. But under light load, stripped of passengers and cargo, fueled only with what's absolutely necessary, and with favorable winds across the deck, the numbers shift. Reduced weight drastically lowers the required speed, while strong headwinds effectively shorten the needed ground roll. If a 747 were ever going to succeed in such a stunt, it would be under those extremely specific conditions, where everything is fine-tuned to give the engines and wings every possible advantage. Another important element is the carrier itself. Modern U.S. Navy supercarriers can reach speeds of over 30 knots. And when steaming directly into the wind, they add a crucial boost of relative airflow over the deck. That airflow is effectively free lift, which combines with the engines and flaps of the aircraft to help get it airborne. On top of that, carriers use angled decks that provide additional clearance and, in some cases, ski jump style ramps on foreign designs that help launch aircraft upward. While the U.S. carriers typically rely on catapults for launch, the principle of deck wind and lift augmentation is the same for a 747. Those few extra knots of lift could make all the difference between a miracle takeoff and a catastrophic plunge into the sea. In terms of cockpit design and pilot workload, flying the 747 from a carrier would be an extraordinary challenge. The flight deck of the 747 is set high above the ground, giving the crew a commanding view on a normal runway, but making it harder to judge distance and alignment on the confined space of a carrier. The pilots would need to carefully manage thrust levers, flaps, and rotation inputs with almost no margin for error. Even in standard operations, rotating a 747 at the right moment is critical to avoid tail strikes. On a carrier, that timing becomes even more unforgiving. Too early, and the aircraft might stall. Too late, and there's simply no more deck left to run on. The landing aspect is even more unimaginable. Unlike takeoffs, which might be achieved under ideal conditions, landings require the ability to decelerate in a ridiculously short distance. Carriers rely on arresting wires and tailhooks to grab aircraft and bring them to a stop within a few hundred feet. The 747, however, has no tailhook, and its landing speeds are far too high for such a system. Even an empty 747 approaches the runway at around 130 to 150 knots. There is no practical way to stop that much mass on a carrier deck without destroying the plane or the ship. So while takeoff might be just within the realm of possibility, landing is firmly in the realm of the impossible. Still, the spectacle of a 747 attempting a carrier launch is part engineering curiosity and part aviation myth. It forces us to think about what makes planes fly and what limits exist in aerodynamics and design. The unique selling points of the 747 are highlighted in this thought experiment. It's a jetliner that redefined long-distance travel, capable of carrying massive loads over intercontinental distances with reliability and grace. Its engineering is robust enough that people even consider it for scenarios so far outside its intended use. Few aircraft inspired that kind of imagination. The sheer power of the engines deserves special mention. Each turbofan produces thrust levels comparable to the total output of many World War II bomber squadrons combined. When all four are spooled up to maximum, the noise and vibration are a visceral experience, felt as much as heard. On a carrier, that raw thrust would push against the limits of the deck, rattling every bolt and steel plate as the aircraft surged forward. For anyone witnessing the spectacle, it would be a mix of awe, disbelief, and raw adrenaline. Another fascinating element is the structural strength of the 747. Carriers are not exactly smooth runways. The pitching, rolling deck of a ship at sea adds turbulence before the aircraft even leaves the ground. The 747's landing gear, designed to absorb the impact of land-based landings with hundreds of tons of weight, would be tested in ways never envisioned by Boeing's engineers. Yet the redundancy and strength built into that undercarriage, with multiple bogies and shock absorbers, might just allow it to withstand the punishment. The aerodynamics of the 747, especially with full flap deployment, provide a glimpse of why this conversation exists at all. Flaps extend the wing surface, increasing lift and allowing lower speed flight. On a normal airport runway, this means the jet can safely lift off without requiring dangerously high speeds. On a carrier, flaps would be deployed to maximum, drag would spike, and engines would strain to accelerate. But the combination of extra lift and carrier headwinds could, in theory, make rotation possible within the limited distance. From a symbolic perspective, the idea of a 747 on a carrier is almost cinematic. It represents the ultimate clash of civilian and military engineering. The largest passenger jet ever conceived, placed in the most extreme aviation environment. It underscores human ambition, the drive to push machines beyond their intended limits, and the fascination with testing what is possible. The 747 itself has already proven its versatility, being converted into cargo haulers, firefighting tankers, airborne command centers, and even space shuttle carriers. That adaptability is part of its legacy, and imagining it on a carrier is just another extension of that spirit. What really makes this scenario resonate with people is the contrast in scale. A carrier is enormous by naval standards, but when you place a jumbo jet on deck, it suddenly looks small. The wings nearly stretch over the edges. The fuselage dwarfs the fighters parked nearby. And the idea of rolling such a massive machine down a few hundred feet of steel feels impossible. That visual mismatch is what captures the imagination and makes the thoughts so compelling. If we think about unique selling points in the context of this story, one of them is the sheer audacity of Boeing's design. The 747 was not just built to fly, it was built to dominate the skies for decades. Its reliability, strength, and performance make it a benchmark against which other airliners are measured. Even today, more than 50 years after its first flight, it continues to serve in roles that no other plane can quite replicate. To see it even hypothetically linked to an aircraft carrier is to acknowledge that legacy of pushing limits. There's also a lesson here. about the physics of flight. No matter how powerful the engines or how strong the airframe, the basic requirements of lift, thrust, drag, and weight cannot be escaped. An aircraft must generate enough lift to leave the ground before the runway runs out, and that equation is unforgiving. The 747 manages it on normal runways through a combination of careful design and powerful engines. But the carrier scenario puts those principles under a magnifying glass, showing just how much margin is required in aviation. Some aviation enthusiasts speculate on how modifications might make a carrier takeoff more feasible. Imagine a stripped-down cargo variant with reinforced landing gear, massive flap extensions, and perhaps even rocket-assisted takeoff pods like those tested in other aircraft. Combine that with a carrier racing at full speed into a strong headwind, and maybe the numbers could work. But that's the point, requires imagination and bending reality to its limits. And that's why the idea fascinates people. When you step back, what you really see is a tribute to the scale of both technologies. The aircraft carrier is the ultimate expression of naval power projection, a floating airbase capable of launching and recovering dozens of aircraft in all conditions. The 747 is the ultimate expression of civilian air travel, moving people and cargo across the globe with unmatched efficiency. Bringing them together in any way, even hypothetically, becomes a symbol of human achievement in engineering and ambition.